Hello, and welcome back to Coding with Brijesh. So, in today's episode, we will be discussing about maximum value of K coins from piles. Now, what does the problem statement tells us? Let's first go through that. There are n piles of coins on a table. Each pile consists of a positive number of coins of assorted denominations. In one move you can choose any coin on top of any pile, remove it, and add it to your wallet. So given a list piles where piles of I is a list of integers denoting the composition of the ith pile from top to bottom, and a positive integer k returns the maximum total value of coins you can have in your wallet if you choose exactly k coins optimally. So what does this mean is like we have been given n pile of coins of on a table where each pile consists of a positive number of coins assorted denominations. We are allowed to choose exactly k coins by choosing any coin on top of any pile, removing it and putting it to our wallet. Now we have to determine the maximum total value of coins that we can have in our wallet. So let's go through our example first. What we are having in an example is we are having input piles. There are two piles. The first pile consists of 100 and 3, and second pile consists of 7, 8 and 9. We are allowed to do two moves and we have to sort it out. So if we remove top from the both piles, we will be having 8. If we remove 2 coins from the second pile, then we will be having 15 value. And if we are removing 1 and 100 from the first pile, we are having answer 101. So obviously our answer is 101. That is the maximum total that we can obtain. Similarly, for example 2, we are having piles. Now here we are having total 7 piles. One pile is having 100, second is having 100, third is having 100, fourth one is having 100, fifth one is having also 100, sixth one is 100, and the seventh pile consists of 7 elements: 1 1 1 1 1 1 and 700, and we are allowed to move for 7 times. So we can choose any of the top elements and any of this. Now as we are having k is equal to 7, if we are just removing this 6 piles, the total will be 600, and that will leave us with only one move available and we can only remove one. So the total of that would be 601. Up if we do like remove the 7th pile directly, like we are allowed to have 7 moves. So 1 2 3 4 5 6, and for the 7th, so that will give us answer of 706. So that is the maximum total that we can obtain. So now let's start with the solution of this problem. So first of all, we will take a n variable that will be the size of the piles, and after that we will be creating one more dp variable that will be a two-dimensional array of n plus 1 size, and inside that we will be defining one more array or integer array of k plus 1 size. Okay, and that will be all for this function, and what we will do is we will create one more function, max value, that will take 4 arguments. First is the where to start for looking for the piles, so from 0 to k. Now our piles, and dp, in which we will be storing our values like maximum count for each of the iterations. We are creating this recursive function so that we can look for each and every piles and each and every type of solution. So first of all, we will be starting for I, then we are having k for the maximum number of uh, possible iterations, then we are having our piles as a list of integer, and finally we are having our dp as a dynamic programming or a two-dimensional array as array of integer array. At the end we will be returning integer from this function as it is required. So what we will do first is we will check if dp of I and k is greater than 0 or not, though it is possible. So if that is true, then we will simply return dp of I and k. So what will this statement do is it checks if the result of for the current index I and the maximum number of coins k has already been computed and stored in a dp array. If it has, then we should not be continuing for this one, and that's why we are simply returning that value. Second, we will be doing is checking with if our I has reached to piles size and or k is equal to 0. If this is the condition, then we will be returning 0 here. So it shows us that we have reached to end of the piles, and we can no longer select any more values from this pile. So if these two conditions are false, then we again will be calling a variable result is equal to, we are simply calling our max value function, but instead of passing 0 here, we will be incrementing the value of I. K will be as it is because that is how many steps we want. Piles will be as it is and dp will be as it is. Now to check for the current iterations, means current value, we are storing one current, let's call it current result is equal to 0. Okay, now we will be looping through our piles, and for that we are creating one j in 0 until piles dot size piles of I dot size dot course at most of k. What does this mean is that suppose in our piles we are having 5 elements or 5 coins, but our moves are only 2, so we can just go for the first 2 and not all of them. So that's why we have done this course at most. If this is the true in this loop, then we will be adding to our current result plus equal to piles of I and j, and once it is done, then we will be checking our result should not be val, it should be where. Same way our current result should be where. So now our result will be result dot course at list of our, again we are calling max value function here because we want to go through other type of scenario. Here what we will be passing for I will be I plus 1. Instead of k, we are here passing k minus j minus 1. So what we are doing here is we are excluding the current elements that we passed. We have checked files and rest of that will be dp. Now outside of this, our dp of I and k, sorry, we actually forget to add this result over here, as it has been done. So it will be our result, and at the end we are returning this result. Okay, so now let's run our tests for this code. And so here we have passed all the test cases. Now let's submit this code, and voila, our solution has been accepted. So this beats 75% of runtime scenarios. So that was all for today's episode, and hope to see you in the next video. Till then, have a good day and be wonderful by liking this video. Thank you so much.